Okay, so we want to simplify this radical, and I do this a little bit differently than the textbook. Don't know if you've seen the other videos that I've posted on this one, but I suggest that you do a little factor tree that you learned way back. You may not remember it, but this is something you kind of learned back in like middle school type thing or so. And I'm going to do a prime factorization of this. So 48 is what, 2 times 24. 2 is a prime number, so I'm just going to continue keeping that one there. 24 is 2 times 12. 2 is a prime. 12 is 2 times 6. That's 2 times 3. Okay, so I'm going to start off working with just the coefficient, the 48 right now, and then I'll deal with the variables here in just a moment. So once you get this factored, it's actually kind of the hard part. What you're looking for are pairs, okay? And for every pair that you see, that's going to correspond to one copy on the outside of the radical. So I have a pair of 2's. So that means if I have this square root, I'm going to have a 2 on the outside of the radical. And then there is another pair of 2's. So I'm going to have another 2. And anything that you move outside of the radical is multiplication. Okay? And then lastly, we see this 3. It does not have a pair. So what I nickname this the prison break method. That you've got all of these people that are in prison, but it takes 2 people to break out. Okay? So as they're trying to break out, one of the 2 people in the pair that's escaping gets shot by the guard, and so they don't actually ever make it out of the prison. Okay, so only one of them escapes. So we got one of the 2's in red that get out of the prison, one of the 2's in green that get out of the prison, and the poor little 3 didn't have a buddy even to help him, so he's stuck on the inside. Now the same is true for all of these z's and x's and stuff like that, right? So we have an x squared. So there's 2 x's. One of those x's makes it on the outside, and I need to give myself a little bit of room here. Okay. So let me scoot this way over, and we had a 3 there. So we've got an x on the outside from that pair. Then we have the y's. Now there's 5 of those. So if I wrote them out, I'd have these, and you'd see that there's 1 that goes out here, and there's another pair where one of the inmates can escape, and then there's still 1 left on the inside, and then the z, well, there's just 1 to start with, so he's got to stay on the inside. And then we can just simplify what's out here. 2 times 2 is 4. We have the x. I'm going to write this with the exponential notation, so that's y squared, square root of 3yz. And that is the simplified radical.